today we will start with cryptography. So what actually cryptography is? Cryptography is the process in which we convert a plain text or the clear text which is readable by a normal human person into a form which is not able to understand, or which cannot be readable in a proper format. So that is called cryptography. So here is a plain text. We apply an encryption process on it and we get a cipher text. And to decrypt it, we apply a decryption algorithm on it and we get our plain text, which was the original one. So this is what cryptography is. And cryptography is of three types. First one is symmetric cryptography. Second one is asymmetric cryptography. And third one is not actually a type of cryptography, but for now you can consider it in cryptography. So the first one is symmetric. What symmetric does, as I told you, we apply an encryption process. So to encrypt something, we need a key, okay, to encrypt our data. Just like a lock. When you have to lock your gate, you use a key, okay. So here we use a key to encrypt our data. And when we use same key to encrypt as well as to decrypt, that is called symmetric cryptography, in which we use single key for both encryption and decryption. Whereas in asymmetric cryptography, we use two keys. One is for encryption and another one is for decryption. So this third thing is hash. Hashing is different from cryptography. Okay. Cryptography, in that we can convert our cipher text, or in that we can decrypt our cipher text. But in hashing, we cannot decrypt our hash function, okay, or we cannot decrypt our cipher text. So in short, we can say cryptography is reversible, whereas hashing is irreversible. But there are also some techniques through which we can decrypt our hash. Let's say I have a cipher text which is hashed, okay, and what plain text of it, suppose it was ABCD, okay. In order to decrypt it, what usually method we follow, we encrypt or we hash every word which we know. Let's say I have a word list of 1000 words, okay. That 1000 words consist of common words. Let's say name, or say place, or just you can say any word. AA is there, BBB is there, and so on. So what we do, we hash every word of our word list and get a pair. Pair in what sense? Like I have my word and I have its hash. So in order to crack our original hash, which was this cipher text, so what I will do, I will just compare my hash from this word list. Like there are 1000 words, so there will be 1000 hashes, and I will compare my original hash with those 1000 hash. Let's say somewhere in that list the word A, B, C, D is also there, and we have its hash. Since there cannot be two different hash for single word, so at a point when we are comparing our original hash with the words, when it reaches this and it compares, okay, this hash is matched with our original one, so it will give a prompt, okay, your original text or plain text was this, which was hashed, okay. And let's say there is a very weird text, something called S4V3 hashtag 123. Okay, so if this word or this clear text is present in our word list, then only we will be able to decrypt the hash of it. Let's say its hash is #2, but this word is not in our word list. So #2 will not be matched with any of the hash present in our word list, and hence we cannot get our plain text, which was S4V3 hashtag 123. Okay, so there are two websites, CrackStation and MD5 Decrypt. And before proceeding to that, there are many hashing functions. MD5 SHA-128, SHA-512, SHA-256, amalgam, I guess, if I'm not wrong. There are many Cipher hashing functions. So let's see if we get the list. Okay, see, there are many types of hashing algorithms such as MD, MD2, MD4, MD5, MD6, and secure hashing function SHA-0, SHA-1, and so on. So if you like, usually we do not know which type of hash it is, so we generally brute force it using this website, CrackStation and MD5 Decrypt. Let's generate a hash. So let's try with a very common word, hello. Okay, so this is our hash of the hello. And one more thing to tell you, hashes are like MD. If you take a particular case, let's say MD5, so the hash function will be always of same length, irrespective of the word. Now if I say COMMON, common, let's say that is our word, and we generate a hash, and you can see they both are of same length. Which this was of 5 alphabet, it was of 6 alphabet. Okay, so let's try to crack this one. And here it says this is a hash, it is MD5 type, and the correct plain text is hello. Now let's try something different or some difficult word which may not be present. S4V3 hashtag 123. See, it says not found. Why? Because probably the word S4V3 hashtag 123 may not be present in their database. Okay, so it shows not found. So it depends whether the hash given is crackable or not, but it is a irreversible process, but it can be decrypted using this way. Okay. Now proceeding further. Main cipher algorithm. There are n numbers of algorithm, but basically if you take CTF into consideration, these are the most basic or you can say most commonly asked ciphers in an introductory or a beginner CTF. So starting from the first, we have our bases: base 32, base 64 and base 85. Bases: base 32, base 64 and base 80. Base 85. So base 32 is always of capital letters, and base 64 will be alpha numeric with plus and slash symbols in it. And base 85, I guess weird or unreadable. Let's find out about that. Okay, so first we'll start with base 32. Base 32. And there are two main websites which you should use in while solving crypto challenge. First one is Crypty, and another one is decode.fr. So this one is Crypty. Here you can see all the types of functions are there, and you can encode and decode both as well. So let's say common word hello, and its encoded part is this. Our plain text is hello and cipher text is this. Here you can see they all are of capital letters. It also consists of alphanumeric, but they will be always of capital letter. And hello 1 2 3. Plain text is hello 1 2 3 and cipher text is this. So these equal to signs are act as padding to our cipher. Okay, whenever you find these equal to signs, just directly go for the bases, because base 64, base 32, they usually have these equal to signs in it. Okay, so this is our base 32. Now proceeding to base 64. Base 64. See, hello 1 2 3. Plain text hello 1 2 3. Cipher text is this. You can see they are alphanumeric. Okay, base 32 will be capital and base 64 will be capital as well as small both. Okay, and hello 1 2 3 1 2 3. Well, I'm not getting plus or slash sign in it, but usually if you see any plus or slash sign in it, so just go for base 64. Now base 85. Base 85 or ASCII 85. ASCII 85. So just look over here. This is our plain text. Man is distinguished not only by his reason but blah blah blah. And here you can see the cipher text which we got is pretty weird, or no one could understand what it means. Okay, so hello 123 gives us this. So while solving this challenge, you may or may not know that it is base 85 or ASCII 85 or not. So you just have to it is kind of hit and trial. Okay, so you can try with base 32, base 64, base 85. It is your luck that you jumped upon the right cipher and you got the plain text. Okay, so this was bases. Next one is our number system. Number system, base 2, base 8, base 10 and base 16. Base 2 is binary, it is octal, it is decimal, and it is hex. Okay, so if you are in Linux, so best way to see the whole binary, not binary, octal, decimal and hex thing is man ASCII. Hit enter, and here you will see for each and every word or every you can say character, you have its octal, decimal as well as hex. So if you are given any, like let's say hello, so you have given this cipher text and you are asked to decrypt it. Okay, so for sure initially you may not know it is either decimal, hex or octal. So you can see here itself, like okay, 150, where is 150? 150 is here, so it corresponds to H. And then 145 it corresponds to E. And other than this, we don't have our 150 or 145 in any other of the line. So using this you can find octal, decimal or hex, and binary is quite easy to find because it has only 0 and 1. Let me okay, so this was one of the challenge which I made for one of our training classes. So this is a cipher test which was given, and easily you will be now able to understand okay which type of cipher it is. It is binary and binary to text, and just put the binary over here, convert, and you will get the flag LPAD Heraferi. So this was the challenge. Okay, now proceeding to third one, which is Rod cipher. What actually Rod cipher is, let's say I have a plain text as A, B, C, D, E, and I say the key is 1. So what Rod does, Rod is the short form of rotation cipher. Okay, so you have to add 1 to each of the particular alphabet of plain text. So if you add 1, so like what you will get after adding 1, the what comes just after A, it comes B. For B it will be C, and for C it will be D, E and F. If I say plain text is A, B, C, D, E, and key is 3. So what ciphertext will be? So A, B, C, D, and E, and something like this. So let's try it online. Okay, so let's say I say a word hello, and these are the total 25 rotations can be there, because there are 26 letters in our alphabets, total 26 alphabets. So if you do rot 26, so it will be the same as itself. So if I perform rot 26 on a hello, it will be hello itself. So if I perform rot 2, or I can say the key is 2, the plain text will be this. Okay, if I perform rot 13, it will be this. So the question arises, how you will be able to identify whether the challenge is of rot 13 or any of the rot cipher or not. So you know the one thing also to tell, these symbols or special characters are not a part of rotation cipher, or rotations algorithm is not applicable on them. It is only applicable on the our characters or alphabets. So if I say my flag format is LPAD and something here, okay, so and okay, let's make it precise. You got the flag. Okay, so the rot format of LPAD will be something capital, I guess. Okay, let's try LPAD and R this, and after this you will be have so I know that my flag format of the particular CTF competition is LPAD, and it is all capital letter, and the ciphertext which I will be given is this. So I can say, okay, this resembles our LPAD somehow. If I rotate it to 13, so I will be getting LPAD. So using this you can try. So this will be your encrypted part, or this is the ciphertext which will be given to you, given in challenge. Okay, you don't know this, but you know the flag format is LPAD, and since you can see LPAD is all capital and the first four letters of a flag challenge is also capital, so it might be a rot cipher. Not exactly we know, okay, which key will be there. Okay, so you can directly brute force here, or you can just try over here for every like 14, 7 and something like this, or you can directly try here, paste your ciphertext here, and it says automatic decryption brute force. It gives you the output of every key. See, plus 13, plus 5 and plus 2, it tries every possibility and gives you the all the outputs which is probable for that ciphertext. So the flag usually is in something understandable or readable format. So here you can see LPAD, you got the flag. Okay, you got this thing. But you have to place the curly braces, and you have to, since there are also underscores in it, so you have to place underscore over here, underscore over here, underscore over here. And you can also see that these are in small, and the one which we got as after decryption is capital. So first you can try this to submit, but a flag is in small letters, so it will be incorrect. The prompt will be showing the flag is wrong or incorrect. So then you have to try another possibility, like you can just try it in small letters. You got the flag, so it's just a hit and try to match. Okay, you got the flag, but you have to try the possibility. It could be without I can say, if this is not there, then your flag will be this. Okay, so likewise you have to solve rotation cipher.